This screencast is about different properties of acids and bases and the types of acids and bases. The very generic definition for an acid is something that it gives up or has a hydrogen ion in it, and a base is something typically that has an OH ion in it. Some of the characteristics are acids are tart or sour tasting. They will change the color in presence of an indicator and can be either a strong or a weak electrolyte. So when you put an acid into a solution, it's going to break up into two components. Typically one of them has an H plus and then the remainder of the negative ion. In a base, they are a bitter taste. They can feel slippery, kind of like soap. They will also change color in the presence of an indicator and be a strong or weak electrolyte. A base, when it dissolves in water, it breaks up into ions as well, and it will usually form an OH, but not always. And then you have some other part of a metal cation usually with it. There are three types of acids and bases. The first one we're going to look at is the Arrhenius acid and Arrhenius base, and these are the most common ones that we think of when we're thinking of acids and bases. The definition is that an Arrhenius acid is a hydrogen-containing compound that ionizes to give the H plus ion. When it's an Arrhenius base, that is a type of a compound that gives up an OH ion. Monoprotic and diprotic, you can even have triprotic. They just talk about how many hydrogens are being released. So you have a graphic here on the bottom. You can see that the HCl is our acid, and as it progresses through this reaction, you can see that HCl gives up a hydrogen to the water, forming a hydronium ion, and it has the leftover chloride ion that is the HCl minus the H plus. Another type of acid base is the Bronsted-Lowry acid and base, and Bronsted and Lowry together combined to find this type of acid and base. In a Bronsted-Lowry acid, you have the hydrogen is, the acid is a hydrogen donor, and the base is a hydrogen acceptor, meaning the acid gives up a hydrogen and the base takes on a hydrogen. You can see an example of the Bronsted-Lowry acid and base here in this reaction, where you have water will give up its hydrogen to this NH3, forming NH4, and the water, what's left over of the water, becomes the OH ion, and it's the corresponding base. So typically what happens is whatever you're starting with as your acid, whatever minus the hydrogen is left over on the product side, that is going to be your conjugate base, or the opposite base. And whatever you're starting with as your base, when it takes on this hydrogen, it becomes the conjugate acid. And so you're going to be expected to label acids and bases along with conjugate acids and conjugate bases. So if you think of the word conjugate as kind of the opposite, so you will start with an acid and have its conjugate base, so whatever's left over, and you'll start with a base and have its conjugate acid, or whatever's left over after you've added the hydrogen. The third type of acid base is the Lewis acid and Lewis base, and this type is not necessarily one we can easily distinguish. In the other two types of acids and bases, you can see where the hydrogen is coming off, or the hydrogen is going in, or the OH even. In a Lewis acid and base, this is a matter of accepting a pair of electrons and donating a pair of electrons. So the acid is the substance that accepts the electrons, and the base is the substance that gives up the electrons. So you would have to draw the Lewis structure first in order to determine if it's a Lewis acid or base.